Hi, everyone. My name is David Blankenship, and I'm joined here today by Caleb Miller, Thomas Kiefer, and Hashim Afzal to present our Fantasy Football Helper Modeling and Performance Overview. Starting first on a project overview, first I'd like to remind everyone our goal. Our goal is to produce a fantasy football draft assistant that provides high quality recommendations and tools for users that are useful in a fantasy football draft. The plan we had to achieve this is to develop a machine learning and a rules-based recommender system, along with a dashboard that includes UI to actually achieve this goal. Some of the important stuff we've done over this quarter so far includes expanding our data set to include an additional 4 years of data. We've decided on a long data format versus a wide, so long meaning that we have individual years listed rather than including several years in one data point. We've also ultimately decided against position-specific models and are using a single model with all the players due to empirical model tests actually giving us better results. And we've also finally finalized some of our features that we'll discuss on the next slide. Here in our data overview, we show the finalized form of our data set. So first we have two targets that are the standard and PPR fantasy points. These are the major scoring systems for fantasy football, and we are using both of them. The features, we see 5 different positional features that are mostly focused on the actual positional performance metrics. And we also have a descriptive statistics that provides a more general and generic statistics that are relevant to all positions. So for those positional features, we have passing, rushing, receiving, defense, and kicking. The major change that we've included in this update is these deltas that we see throughout the various positional features. These include stuff like the delta passing touchdowns or the delta rushing yards. These are a way to capture the year-to-year changes in player performance to kind of show inclining or declining performance over the years. As to the descriptive statistics, we include a rolling 3-year average for the PPR and fantasy points, again, to kind of incorporate a window of performance over time to kind of help show this change in the player's performance.
So here's a brief overview of our modeling pipeline. First, we split the data into 80% train and 20% test. Next, we fill null values with zeros. If we think about the nature of our problem, this makes logical sense. If a statistic is missing or null for any player, then that just means that statistic was absent for them, which represents 0. Next, we apply scaling to our numerical features. We have custom scalars implemented for each model type depending on performance. And lastly, we one-hot encode our categorical features and feed our data into our models.
So with our modeling approach, we wanted to test out a few different models to see which one would give us the best predictive performance. And in the end, we opted for the following 6. We went with linear regression because we felt it would be able to capture linear relationships in the data and serve as a good baseline model to evaluate our more complex modeling approaches. We went for an XGBoost model because it's good out of the box. It's a tree-based model which would support regularization as well as hyperparameter tuning to reduce the overfitting and improve performance. A light GBM model, which is also a gradient boosting framework that is highly efficient and fast and also offers strong out-of-the-box performance on larger data sets. We went for a stacked model, which would kind of combine the strength of our XGBoost and MLP regression model to capture both non-linear patterns and complex interactions. And then 2 deep learning methods, the first one being a multi-layer perceptron, which is a basic neural network architecture capable of modeling non-linear relationships with 1 or more hidden layers. And then finally a deep neural network, which is a more complex neural architecture with multiple hidden layers, enabling the capture of intricate patterns and hierarchical feature interactions within the data. So to judge the effectiveness of our models, we opted for the following metrics, with R squared being how much variance in the data our models were capturing, as well as RMSE to kind of tell us how far our predictions were from the actual true values. And so for our first modeling pass, we saw R squared values ranging from 0.493 with our linear regression model, as well as 0.424 with our multi-layer perceptron, and our predictions being on average from 55 to 60 points off. We saw similar figures on our PPR scoring models as well, with now the XG Boost performing best with an R squared of 0.469 and an RMSE of 64.4 points, with our poorest models being the Deep Neural Network at an R squared of 0.33 and an RMSE of 70 points. So while the RMSEs are higher, it's also key to note that PPR fantasy scoring does inflate player production. So that may be one reason why the RMSEs are so high. But in totality, we felt like these numbers were not reflective of a good fantasy football predictor, and our models were essentially plateauing even after hyperparameter tuning. So there was still work to be done on how we could improve these models.
So as mentioned previously, our initial models were reaching some sort of wall and plateauing. Our performance was reaching an R squared of 0.49 for standard scored leagues and an R squared of 0.47 for PPR scored leagues. We believe that it's probable that we were approaching the predictive limits of our dataset. To combat this, we explored further feature engineering through additional features such as delta-based metrics and year-over-year trends. Our hope is that this can capture short-term momentum as well as highlight consistency, breakout potential, or decline. We also expanded our data coverage through additional web scraping, adding features such as player injury history and NFL experience. Lastly, we refined our hyperparameter tuning to finalize our models. After implementing our new approach, our model performance increased significantly. For standard scoring models, we saw performance increases of 10 to 15%. Our best performing model was our stacked model that included XGBoost and a multilayer perceptron, and interestingly, our worst performing models were our multilayer perceptron on its own, along with the deep neural network. These two models were expected to be our best performing, which was just an interesting takeaway. For our updated models, we're seeing predictions that are between 41 and 45 fantasy points off on average. Shifting gears to our PPR league models, we see similar increases of 10 to 15% in terms of variation explained. Our best performing model for this scoring type was LightGBM from Google, and similar to standard scoring, the worst performing model was the Deep Neural Network with an R squared of 0.581. An interesting takeaway from this is that our best performing model from standard scoring, which was our stacked model, is our third worst model for PPR scoring. Similarly, the multilayer perceptron was one of our worst models for standard scoring, but it's our third best for PPR scoring. Our predictions for these models are between 51 and 54 fantasy points off on average.
Thanks, Caleb. We also wanted to give an update as to the current status of our player recommendation system, the other part of this project. So our whole overall goal is to incorporate some customized rules and those results we were just discussing into our recommender system so that it aligns with fantasy football best practices while also still producing interesting and unique player predictions that provide extra value. So you can see some of those custom rules there, like avoiding quarterbacks and tight ends in early rounds. And it will also incorporate roster limits and live draft results, so who's been chosen already, to update those player recommendations for you in real time. The system will use those predicted points that we talked about from our machine learning models and a new value over replacement value that kind of represents how much how much better a player is than their peers at their position. And the finalized recommender system will be applied seamlessly to a dashboard UI for ease of use and customization for anybody using it. Speaking of our dashboard UI, we'll also be giving a status update on that here as well. So currently the UI, which is in Dash, displays draft settings and an interactive player draft pool that you can see all of the players available. The dashboard prompts the user to input draft selections as they happen from that draft pool of available players. So that player gets removed, so it's only players available to you that haven't been drafted, and all players from the 2024 season, or I should say only players from the 2024 season, so any and all players from that season, are available in the player pool. You can also add a custom player that is not represented if they're not already in the draft pool, just in case something strange happens and you accidentally pick the wrong person. We would also like to polish the interactive draft history and roster breakdown section. They're not separated by team just yet. It only just shows the live draft order as it happens. So we'd love to be able to see how each team is doing, see what players have gone to which team, and just the overall history. So we're going to polish that up as well. Lastly, here we have our next steps to just wrap up this capstone project at the end of the quarter here. So first and foremost, we need to optimize our recommender system. We need to finalize the hard rules logic that we've incorporated so far and the draft structure, organization, and customization. We also need to manually go through some mock drafts and just pick some players, see how the model is doing, evaluate the UI, and see if it's optimized to be working with the recommender system, things like that. Speaking of the UI, we want to polish that up and make it a little bit more interactive. So building and integrating a custom visualization functionality is a big check on our to-do list. And incorporating functionality to select PPR and standard fantasy models, so the different types of scoring there. And then lastly, we need to update our documentation and start preparing for those final reports and presentations that we still have. So we need to update our README to include all of the DSCI 592 work. And then we also need to just start brainstorming and thinking about how we want to divide up the final presentation, our strategy for that. And lastly, we need to plan and record a walkthrough of a draft or an interaction with that finalized UI once we have it. So just making sure that it's working as well as it can and that everybody knows how to use it.